So let's begin. So we're wrapping up our discussion on transformation of random variables. So where y equals, so what you have is y equals g of x, right? And so the expression that you see boxed on your screen is applicable regardless of whether the function is one-to-one or whether it is not one-to-one. So it's applicable to monotones, it's applicable to monotonically increasing, monotonically decreasing, as well as to non-monotonic functions. Okay. And here, so who can remind me what xi's are? So yes, Mohsen.
So the roots of
Okay,
um,
good. Right. So here what xi's are. So let xi be the roots of y equals g of x. So there's an equation y equals g of x, right? And xi's are the roots of y equals g of x, and they may not be unique, right? So there may be many roots. Okay. And this is the expression that you see here, and we're going to try to apply them in at least one example now, right? Now, but I'm going to start out with this example one. So we're doing examples, remember, of some transformation examples. We're going to do, I think, three of those. The first one I have listed here is what I left you off with at the end of the last class. So, and did anybody get a chance to solve this? I think Nazish did so already at the end of the class. Anybody else who has an answer or a way to go about this? Gmaz?
सर ये इसमें दो पॉसिबिलिटीज होंगी ना कि एक तो नेगेटिव वैल्यूज ऑफ एक्स द
Yeah.
फंक्शन इज जीरो द ट्रांसफॉर्मेशन बेसिकली द ट्रांसफॉर्मेशन फंक्शन इज जीरो
Yeah.
तो हम उसको एज अ डिस्क्रीट केस ले सकते हैं कि प्रोबेबिलिटी नहीं व्हेन y इज इक्वल टू जीरो तो वो वी कैन इंटीग्रेट फ्रॉम द पीडीएफ ऑफ x
Yeah.
फ्रॉम माइनस इन्फिनिटी टू जीरो तो दैट विल बी गॉसियन केस आपने कहा था तो 1/2 आएगी ना उस केस में
Yeah.
तो तो बाकी जो x ग्रेटर देन जीरो है तो उस पे ऊपर वाला फार्मूला वी कैन अप्लाई
Okay. Okay. So and ऊपर वाला formula में, because for greater than zero is y equals x. So if you apply the formula above, so that's just the same function, right? So the slope is one. The root is also x equals y. Okay. So it's a simple, straightforward transformation. I am not going to apply the formula per se. I am going to try to motivate this through provide an answer through the CDF approach, right? So I'd say if small y equals g of x, let me try to find out the PDF on y first, right? So the PDF on y is the probability that capital Y is less than equal to small y, right? And this is the probability that g of x is less than equal to small y, right? And what do you think this should be in terms of the probability on x, right? So this is what g of x looks like, right? If this is x and this is g of x, so the function is zero here, right? And this here, okay? Or there's a certain y here, so there's a certain y here, and you're trying to find the probability that capital Y is less than or equal to small y. What is this probability in terms of an event on x? What is this event in terms of an event on x, right? So what is this event? Capital Y is less than or equal to small y, equivalent to in terms of an event to x on x. Okay, there's a one-on-one mapping. I claimed here this is actually the same as this. Right? The probability that capital Y is less than equal to small y is exactly the same as the probability that capital X is less than equal to small y. Okay? Yeah, this Shoaib was here. Shoaib is here now. So you get the point?
Yes, sir.
Right? So this event, the capital Y is less than equal to small y, is nothing but capital X being less than small y. Okay? So I'd say, yeah, this is equal to the probability that capital X is less than equal to small y, right? And which is nothing but fx of x, right? So what we have is that fy of y equals fx of x. Now this may lead you to believe that the PDF on x must be the same as the PDF on y. In other words, the random variable capital X must be the same as the random variable y, right? And that's actually not so. And the reason why Gmas.
सर ये fx of y नहीं होना चाहिए मतलब ये from the probability.
Sorry. So fx of 1. Right. So Maz, I want you to comment on this expression here that I have at the end. And which says that fy of y is the same as fx of y. Same function form. Is this correct, or is there something that we're missing here? Ji Isha?
Sir, I think that it is correct given that x is greater than or equal to 0.
Given that y is greater than or equal to 0.
So would be the same, isn't it?
But remember, we're trying to find a function on y. Right? So the y can take on any value.
Okay.
It can be anywhere. So y can take on, and so y can take on any value, and we're trying to find a function of that y. And we see that.
Sir, isn't it that for y it would only be y is greater than 0?
Yes. So
instead of having equality as well.
Right. So actually, yeah. So this is the case when y is greater than or equal to 0. And this function form does not hold true when y is less than 0.
Sir, would we not have an equality here? Like, wouldn't it just be y greater than 0?
Doesn't really make a difference. So,
sir, if we just look at the sketch, it seems to be a little confusing because for all values x less than 0, we do have y equal to 0. So if we include an equality here, how would it not make a difference?
Because the function is continuous. ठीक है, तो मैं अगर यहाँ पे मैं ये डाल दूँ greater than equal to की जगह ये डाल दूँ, तो does the function change?
Sir, that for change, then we have it.
Isha, you're
am I audible now?
You're breaking up. I don't know कि ये मेरे end पे मसला है.
I guess it would be on my end.
Right. So why don't you give it a go again?
Is it better now?
Yes. अभी बोल के देखें तो बताएंगे.
Okay. So what I was saying was that when we change the inequality, when we're looking at x,
yeah,
it doesn't make a difference. Because if we observe the curve that we have for g of x against x,
yeah,
so we do have the point on origin, which is x is equal to 0, and we can clearly see that, yes, y would be the same there as well. But when we are operating it in terms of y, I just have this confusion that if we take y is greater than or equal to 0, we will have all values of the x-axis, which is on the negative x, which are all 0, also being in that inequality. So how would it be the same if we write y greater than or equal to 0 or if we write y greater than 0.
So I'm not exactly sure what you're trying to say. अगर ये continuous random variable होता, ठीक है, तो फिर तो कोई मसला नहीं होना था, right?
Yes.
And if even if you have that equality there or not an equality there, all that means is that the point that you're concerned about is exactly small y equals 0. Okay, small y equals 0 पे क्या होता है?
Sir, ये मैं exactly ये कह रही हूँ that if you look at
इस फंक्शन को ड्रॉ कर लेते हैं तो then we can see.
sir, okay, ठीक है.
फंक्शन को ड्रॉ कर लें कि यहाँ पे अगर इक्वालिटी में लिखूं या ना लिखूं उससे कोई फर्क पड़ता ही नहीं पड़ता.
Okay.
Right? So let's say I don't have that equality as you suggest. I don't have that equality. Here's y is greater than 0. Right? What about y is less than equal to 0? What happens there? Isha?
Sir, 0 होगा.
0. So the probability is 0. The 0 for y is less than equal to 0. Okay? Right? And why is that? Because small y can never be less than 0. Okay? So it's to say otherwise. Okay? Small y can never be 0 because the maximum value the small y can take is 0. Okay? Acha. Let's sketch this out a bit, like this function, right? So what does this function look like? If this is the y-axis, right? And this is the function, which is fy of y, right? What this is telling you is that for all values of y which are negative, the function is 0. Okay? What happens for y is greater than 0? Ji Shoaib?
So Gaussian आ जाएगा क्योंकि we assume कि x is Gaussian, isn't it?
हाँ, so assuming कि वो Gaussian है तो वो इस तरह की shape आ जाएगी.
Exactly.
Right? And then that means that there's a discontinuity here. Right? Okay. I mean, for all values of small y which are less than 0, the function was 0, and it all of a sudden it jumps up, right, to some positive number. All of a sudden it jumps up to some positive number. And what is this number here? Jahan pe it jumps up. What value is that? That value is, so this height here. This height here is what? This height here is fx of 0, or which is actually fy of 0 as well. Okay? So which is fy of 0. Okay? Ji Ghazi.
Sir, it's visible now. I get what you meant.
हाँ तो आपको greater than equal to 0 करूँ या नहीं तो जैसे
Yes.
discontinuity there तो discontinuity को हम वैसे ही वहाँ पे equality को नहीं डालते.
Right.
जी गाजी.
So यहाँ पे कोई CDF PDF में कोई हम confusion नहीं हो गई? PDF थी ना Gaussian तो CDF तो
Oh, sorry. Oh, sorry. Thank you for. Yeah. So let's say any shape, right? So this was any shape, right? This jumps up, and it is a monotonically increasing. That you're right. Okay. So let me reduce the. So let me do something like this. Yeah. हाइट कम कर लेते हैं, ठीक है, और फिर जो है some form, right, which maximum जाके कहाँ पे जाता है by the way? So it converges to 1, right? And this height, what is this height? This is the CDF of x evaluated at 0, which is actually nothing but the probability that x is less than or equal to 0, right? Doesn't make a difference because x is a continuous random variable, whether I have an equality there or not. ठीक है? अच्छा, अब here this form is fx of y, right? This is 0 here, and then you have all of a sudden there's a jump there somewhere, okay, at y equals 0. So if I were to compute the PDF, what would that be, right? For the PDF, I just need to differentiate this function, right? This red function, right? And that right function is going to give me what? If I differentiate this function is going to be 0 for all values of y, which are less than 0. And at y equals 0, there's a sudden jump. And that would mean that you have an
Impulse.
What height would that impulse be? जी शोएब?
सर हाफ होगी because PDF को हम इस तरह भी देख सकते हैं कि it is the probability evaluated at that point. Okay,
Right. So I'll generalize this. Okay. So this is just fx of 0 times delta y, right? And this is general. अगर आप जो Gaussian के जो symmetric Gaussian के case में सोच रहे हैं ना, so this fx of 0 is indeed half. ठीक है? Right. So you just remember कि ये fx of 0 is actually the probability that x is less than equal to 0, right? And then what else do you have? And then what you have is this is fx of y times u of y, right? Which just indicates here for all values of y which are positive, the function takes on exactly the same form as the PDF on x. Okay? So this is called a mixed random variable. Ji Ghazi.
Sir, I still think that one possible solution to this is just the f of x of y,
Yeah.
given that x is greater than 0. That should also produce the correct answer for the distribution.
So greater than 0 would not have that impulse.
Huh, but I feel like it would give the same correct answer. Just the x.
Because there's no impulse there.
But y is equal to x, right? For x is greater than 0.
Yeah.
So you just want the probabilities of x when
Yeah.
you know that x is greater than 0.
Yeah, but then what happens so you're ignoring the fact that y can take on a mass at y equals 0. Right? So this is no longer a continuous random variable, if you will, right? Because for all values of x which are less than equal to 0 have been collected together, and all of them, that entire interval maps to capital Y equals 0. The random variable being equal to 0. Okay? So there's a probability mass there. Right? And so if somebody asks, yeah, what is the probability that this new random variable capital Y is equal to 0? That answer is not 0 anymore. Get it, Ghazi?
I think so, slightly.
So try to think about this. So I'm writing out the answer here. So this kind of a random variable, by the way, is called a mixed random variable. So आप जो suggest कर रहे थे ना, वो that's slightly different. So this is the answer. And we say कि यार this is a mixed random variable. Why? Because its PDF not only has a discontinuity, it is continuous in some places, it has a discontinuity in some other places. Okay? It's not that step all the way. Okay? If you compute its PDF, the PDF has impulses, right? If you compute the probability mass function for this, and I ask you, okay, what is the probability that this random variable is equal to 0? that probability is not 0. That probability is actually equal to the probability that the random variable x is less than or equal to 0. So in that entire interval maps to y equals 0. Okay? So this is how a half-wave rectifier, basically, this is the effect of a half-wave rectifier, right? Okay, so this is a mixed random variable. Ghazi, you can go ahead and see that वो जो आप मेरे ख्याल में कह रहे हैं कि fx of y given x is greater than 0, ये कह रहे थे आप, right? इसको ट्राई कीजिएगा, that you will not get the same.
I think I get it.
You will not get the same answer.
Difference है.
ठीक है, so this will.
आप कह रहे हैं कि ना सारी जो जीरो की जो लेस देन x की वैल्यूज हैं वो जीरो पे मैप हो रही हैं, तो
yes, yes.
जीरो की एक बहुत स्ट्रिक्ट प्रोबेबिलिटी हो,
और जीरो के मास के ऊपर प्रोबेबिलिटी, so there's a mass that exists at y equals 0. ठीक है, कंटीन्यूअस रैंडम वेरिएबल्स में मास एग्जिस्ट नहीं करता किसी जगह पे.
ठीक है, I get it. Thank you.
ठीक है, अच्छा. All right, so so for example, if I were to sketch this out, let's say we sketch this out, right? So if fx of x, or this was zero mean random variable with variance sigma squared, then fy of y, so this is fy of y. What would it look like? It would have एक तो this thing here, ठीक है, and is 0 everywhere here, and then it also has an impulse, right? And I'll graphically depict that through this. So this engrift impulse, which is of height half. Okay, so there's an impulse residing at y equals 0, and then for y is greater than 0, it's exactly that same Gaussian bell curve shaped. Okay. All right. Any questions about this before we move to the second example? Okay, so here's example number 2. Okay, so if I say that x is an exponential random variable, right? So let's assume that this is e raised to power minus x u of x, right? So this is an exponential, x is an exponential random variable, which is of mean. What's the mean here? G Josefa, mean क्या है इसका?
So 1.
Good, right? So the mean is 1. And let's say I get the function I gave you is this. Right, which is essentially क्या है? Flooring है. Now, what kind of a random variable would y be? Would that be a continuous random variable, or would that be a discrete random variable? जी शोएब.
I think discrete होगा because जो for instance 4.1 4.2 ये सारी values रहेंगी, so 4 होगा 5 होगा, integer values होंगी, so that will be a discrete.
Right, so that means, so y is going to be a discrete random variable. It's not going to be a continuous random variable, right? And this is actually called quantization, if you will. So आपके पास random variable एक कोई input आ रही है, ठीक है, which is continuous, and then you're quantizing it into a bin, right? Just like your ADCs work, right? And this one way to quantize it is to just do a flooring, and I can play around with this. I can multiply this with some other, mod operation लेके, actually mod नहीं, so flooring है, ठीक है? So I can do other mathematical operations here as well, which can reduce a continuous input to a discrete output. ठीक है? That's an EDC. Okay, so the conversion that you have here is just a simple flooring operation, right? And given the PDF on X, you're required to find the characteristics of the random variable Y, which, as Shoaib said, is a discrete random variable. Okay? So if it's a discrete random variable, I would rather find the probability mass function of Y. How do I find the probability mass function of Y in its general form? Right? So I know that Y is an element of what? Is an element of the set 0, 1, is an element of all non-negative integers. Okay, all the way up to infinity. Right? Which is essentially, हम इसको अक्सर Z plus भी कहते हैं. Right? How do I find the PMF? Right? So if I say, what is the probability that Y equals K? For any K, which is an integer, which is a non-negative integer. क्या ख्याल है? How do I compute this? Razi, आपका हाथ पहले से क्योंकि खड़ा हुआ है, तो I'll pick you up. And
क्या? So I would say कि आप बस integral लेते हैं.
Yeah.
F of x का k से k plus 1 तक.
Good, right? So this is actually, so you're right, this is the probability that K is less than Y is less than equal to K plus 1. Right? And does not really matter कि आप जो है चलें वो फ्लोरिंग है क्योंकि तो ये होना चाहिए strictly speaking. ठीक है? So because all of the values of X which lie in the interval from K to K plus 1 actually map back to K, right? If it's between 1 and 2 or 1.1 and just before 2, all of those values of X are going to map back to Y equals 1. Okay? And therefore, this is equal to integral from where to where? From K to K plus 1 of what? E raised to power minus X dx. Right? And this actually turns out to be equal to e raised to power minus K minus e raised to power minus K plus 1. Right? So for K is an element of Z plus.
Sir, I had a question. Shouldn't X be between K and K plus 1 if you're finding a probability of Y equals K?
Thank you.
Okay, thank you.
ठीक है. अच्छा जी. So this was pretty straightforward. Right? Let's do this example 3. Which is that Y equals X minus right. So these questions were actually an exam question a few years ago. So now you're required to find the PDF on Y. So the first question would be, is Y a discrete random variable, a continuous random variable, or a mixed random variable? क्या ख्याल है? Ali?
डिस्क्रीट ही होना चाहिए.
डिस्क्रीट होना चाहिए, क्यों?
इससे पहले फ्लोरिंग वेरिएबल है जो x आपने लिया.
Yeah, flooring. Okay, so floor of X is discrete. That I understand. What about X? X, is that a discrete random variable or continuous random variable? G Mohsen, do you want to
सर
say
ये
something?
मिक्स हो जाएगा. सर ये मिक्स नहीं हो जाएगा फिर.
Okay, mix.
मिक्स वेरिएबल हो जाएंगे.
All right. So who raised his? Mohsen, आपने पहले हाथ खड़ा किया था. You want to say something?
Yes, sir. So yes, cyclical होगा between all integer values of X. तो वो sawtooth टाइप शेप होगी इसकी, तो ये कॉन्टिन्यूस बन जाएगा आई थिंक।
कंटिन्यूस बन जाएगा। ओके, सो आप जो सॉटूथ वाली शेप जो है फंक्शन की बता रहे हैं, राइट?
यस सर।
राइट। सो माज आपने भी हाथ खड़ा किया था।
सर ये कहना था सॉटूथ ही बन रही है।
राइट, गुड। राइट, सो सॉटूथ बनेगा। और जो कैन यू से समथिंग अबाउट वाई, के वाई की लिमिट्स होंगी कुछ या नहीं होंगी? I mean, I claim that y will always be in a certain interval. I mean, can never be
So
greater than
between 0 and 1 होना चाहिए।
0 to e power minus 1
0 and 0. माज आप क्या कह रहे हैं?
1 over e
1 over e.
yeah
Okay. So essentially, you see what you have here is something called the quantization error. And you're saying कि जी मैंने कोई चीज जो है quantize की है, and I just want to see कि how far away is that quantized version, or what's the distance of that quantized version, or the difference of that quantized version from the actual input that I was quantizing, right? So this is that error, right? And the easiest way to try to understand what's going on, or how we'll go about this transformation, is to actually plot this function, right? So as Mohsen suggested, so let's see what that function is going to be. Okay? So this is x and this is y, and so we're working with the same example, or with the same so fx of x. Fx of x is still e raised to power minus x, is still that exponential random variable. So if it's still that exponential random variable, I know that x is always positive, right? So I don't really need to bother about negative values of x. Okay? Now, all you do is you just sketch this out, right? So when x is in between 0 and 1, ठीक है? So Ali, अब मैं आपसे बात कर रहा हूँ. So when x is in between 0 and 1, what is the floor value of x? That floor value of x is 0. ठीक है? So essentially between 0 and 1, y equals just x. ठीक है? So this will be a straight line of a slope equal to 1, right? From 1 to 2, what happens? Ali? When x is in between 1 and 2, what is the flooring of x? What's the floor of x? Ali?
टुवर्ड्स 2 आएगा ये।
नहीं, जब x 1 और 2 के दरमियान में, तो फ्लोर कहाँ पे आएगा?
0 की तरफ अप्रोच करेगा नहीं।
Floor of x क्या होगा? So when if I say x is any value between 1 and 2 and not including 2, इस interval को मैं floor कर दूं, right? Any value in this interval, I floor that. What do I get? I mean, I'll get 1, right? So flooring करूंगा anything between 1 and 2, I floor this, I'm going to get 1, right? So यहाँ पे, therefore, the difference, which is going to be between which is that x minus the floor value is 1, right? And x is between 1 and 2 is just simply a straight line once again, okay? Which is actually equal to x minus 1, right? So, and x minus 1, if I plot it out, exactly, he sawtooth as somebody else suggested, right? Okay? And so on and so forth. And this goes on and on, all the way up to infinity. Okay? And this is 3, this is 4, and this is 5, and so on and so forth. Okay. Now, this tells me, Maz, that y can only be between either 0 or 1. The maximum value y की 1 है. Is in between 0 and 1. Okay? If I were to have this rounding, by the way, so y minus round of x कर देता, तो फिर ये कहाँ से कहाँ तक होती? So maybe I can leave that off as an exercise. I mean, a very nice extension to this would be, okay, if this was y minus x minus round of x. Okay? So then the difference is going to be G Mohsen.
सर ये नेगेटिव वैल्यूज में चला जाता फॉर
नेगेटिव
एक्सीडिंग
और प्लस पे भी जाता है।
हाफ
हाँ, सो -12 to +12। ठीक है, अच्छा, लेकिन बहरहाल, सो आवर ऑब्जेक्टिव इज टू नाउ to try to find the PDF on Y. Now we can do it two ways. So I'm going to do it first with the CDF approach, right? And then I'm going to apply the formula that we derived above, right? So, and we're going to see that we get the same results with both methods. Of course, we should. So for the first method, I just start with the basics and I just try to find the CDF of Y. Right? So all I want to do therefore then next is I need to find out here this event that capital Y is less than or equal to small y. I need to find some events on capital X, right, which are equivalent to this event capital Y is less than or equal to small y. Okay? What would that be? So ये say ये एक कोई Y आए, right? So this ये क्या value आएगी by the way? This will be Y.
Sir, why ही आएगी?
Y आएगी, ये वाली क्या आएगी ईशा?
1 plus y.
Exactly, good, right? So this is y plus 1 or 1 plus y, you're right. So this is 1 plus y, this is 2 plus y, this is 3 plus y, and so on and so forth. So the probability that capital Y is less than or equal to small y, can I map that to a probability on X, some probability on X? Think about this for a little while and see somebody can give me the answer. Anji, anybody has an answer to this? जी मुआज,
सर वो यूनियन ऑफ इवेंट्स मतलब इनकाउंटेबली इन्फिनिट इवेंट्स है ना, तो हम यूनियन कर सकते हैं कि कैपिटल X इज ग्रेटर देन is between x and x plus y or k and k plus y, where k is belong to 0, 1, 2 and
excellent, right? So you have is कि ये जो event है ना, capital Y is less than or equal to small y. This is actually a union of lots of events, and let that be over k, right? K equals 0 to infinity, and we है किसका union, which is कि जी k is less than x is less than equal to k plus y, right? So it's this event plus this event plus this event, or union of plus this event and union of this event, and so on and so forth, all the way up to infinity. Okay? So the event that capital Y is less than or equal to small y is the union of all of these events, and these are infinitely many, right? Which are countable though, right? And since all of these events are mutually exclusive, I can say I can replace this with a summation. So this is k equals 0 to infinity, probability that k is less than x is less than equal to k plus y. And how do I evaluate this? I just integrate, right? This is k equals 0 to infinity, integral from k to k plus y e raised to power minus x dx. This is k equals 0 to infinity, and I'm going to skip a step here. This is e raised to power minus k plus e raised to power minus k plus y, right? And of course, this is only when 0 is less than y is less than equal to 1. Okay. And what about the PDF? So PDF is just simply the derivative of the CDF. And what would you get here? So if I differentiate, I mean, this first time is going to go away because that's nothing but a constant. Okay, that's going to go away, right? And यहाँ सिर्फ y यहाँ पे आ रहा है. So this is what's going to be left in the, so this is d by dy k equals 0 to infinity e raised to power minus k, but that's nothing but a constant times e raised to power minus y. Okay, you differentiate that. This is going to be minus actually, so ये minus यहाँ पे minus है, sorry, and this becomes plus, and this is e raised to power minus y times k equals 0 to infinity e raised to power minus k. So what is this equal to? So this is e raised to power minus y. What does that series converge to? Does that series converge? So does that series converge? Right, so this is 1 minus E inverse. Okay, so just as that infinite sum formula, if you will. Okay, so this is method 1. Any questions about this before we go to method 2? And in method 2, I'm just going to use the formula. Isha, go ahead.
Sir, I'm not sure if this is a very valid question,
Yeah.
but what if we had our y to be placed at the value of 1 itself, where the discontinuities occur, and how would we?
Did you please go? फिर से बोलिएगा.
Sir, जो example आपने अभी ऊपर करवाई है,
Yeah.
for that very scenario, what if we had y to be exactly equal to 1? Like the line that we drew for y, had it been coming at the point of 1, फिर x discontinuities पर होता या क्या होता?
Doesn't make a difference, right? The reason why it doesn't make a difference is because x is continuous, right? And the probability that x is going to be exactly equal to 1 or exactly equal to 2 is 0. Okay, so we don't need to be concerned about that, right? If there was some mixed thing going on, then we would have had to be careful. I'm not sure if I answered your question here. Lekin जो discontinuities and doesn't in the function itself, that doesn't really matter because x is continuous.
Okay.
ठीक है, और आप अगर थोड़ा देखो कि मैं I've been sort of careless कि यार equality कहाँ डालनी है कहाँ नहीं डालनी, and the reason is because the random variables are continuous. The probability that the random variable is equal to something is 0. I don't really care that much. Okay. Achha, so I'm not going to use a formula here. Formula kya tha? And let me write it down again. So this was KR xi's are the roots. If those are the roots, then fy of y is just simply summation over all of the roots, and you have fx of x divided by dy by dx absolute, right? And you make this. Take a substitution. Acha. So what are the roots here? What are the roots for this example? How many roots do you have? So any given y, how many roots do you have this equation? Mohsin?
So infinite amount of roots. Sir.
Yeah, the infinite amount of roots, right? So the roots are basically xi is actually equal to I plus y, right? Where I equals 0, 1, 2, all the way up to infinity, right? So that is an ith root. So there are infinity many roots, right? So which the roots are either y plus 1, y plus 2, y plus 3, y plus 4, and so on and so forth, all the way up to infinity. Okay? So this summation really is then is going to be an infinite number of terms inside that summation. Okay? So then I'm just going to use a formula, right? So this is, what is fx of x? This is e raised to 1 minus x u of x, right? And divided by the slope. Slope kya hai? At each and every, so you're looking at this graph, okay, and at each one of the points where the roots exist, so for each one of the roots, what is the slope? Yahan pe slope kya hai? The slope is 1 here, right? Because it's a straight line of slope 1. Yahan pe bhi 1 hai, yahan pe bhi 1 hai, right? Yahan pe bhi 1 hai, yahan pe bhi 1 hai. So at each and every one of those roots, the slope is 1. So dy by dx evaluated at each and every one of the roots is equal to 1. So I don't really need to care about the denominator here because that's 1, right? So dy by dx absolute equals 1 at all the roots, right? And this needs to be evaluated at where I plus y. Okay, and this is from 0 to infinity. So what do I have here? Then this is I equals 0 to infinity e raised to power minus I plus y, and the underlying assumption is that I'm just looking for y between 0 and 1 because the roots only exist for these values of y, and otherwise it doesn't. The roots do not exist. Okay, and this is exactly the expression that we have up above, and I'm going to write the answer directly. So e raised to minus y divided by 1 minus e inverse, right? It's the same answer. So this is that one application of the relationship that we derived above, right? And for your information, this was I think a midterm problem a few years ago. Okay. Any questions before I move to the next section? पूछ ले यार कोई. Somebody asked me a question. चले. जी माज.
ये लास्ट वाली चीज क्या बताई थी आपने u of x वाली, मतलब कि 0 और 1, थोड़ा सा वहां पे कंफ्यूज.
हाँ, so मैं ये बताया था कि so this point here, right? When I say that the roots for this example are this, right? This is only when 0 is less than y is less than 1, right? Because if small y is not within these values 0 and 1, there exists no root to this equation. ठीक है माज?
ठीक है सर.
Right, so that's what I meant. कि अगर y जो इस इंटरवल से बाहर एग्जिस्ट करता है so then there's no solution. There are no roots, and therefore the PDF there should be equal to 1, right? So I mean, so the actual answer is yeah. 0 is less than equal to y is less than 1, and a 0 otherwise. ठीक है, वहां पे भी यही होना चाहिए, 0 otherwise. Okay. All right. So if last chance, no questions, I'm going to move on. All right. So the next section, which is probably the last section we're going to do in this chapter, is evaluating tail probabilities, right? So tail probabilities, I think we did mention this कहाँ पे मेरे ख्याल में Q function के वक्त we made mention of this, right? So there's something called a tail probability, and the tail probability is simply defined as the probability that a given random variable is greater than equal to some, so is greater than some x naught, right? This is a probability. This is the tail probability. This is the tail probability. And essentially this is, if you have a PDF of a random variable, and if this is some x naught, this is the tail probability, right? I mean, we all know this, right? So this is the probability that x is greater than x naught. Now, it is often the case that the how can you find the tail probability? You can find the tail probability by integrating the PDF, or if you have available the CDF, essentially you would have to have the CDF, because you know that this is equal to 1 minus fx of x naught, right? So if you have the CDF available, evaluating the tail probability is no problem. Okay, but in many cases the CDF does not exist in closed form, right? Who can tell me of a very, very important scenario or in a very, very important random variable for which the CDF does not exist in closed form? G. Mohsin.
So Gaussian,
right? So Gaussian ka CDF does not exist in closed form, right? And that's a very, very important random variable nevertheless, right? So we would want a way for us to be able to approximate these CDFs or approximate this tail probability. Now you can say, okay, yeah, we do have computing platforms available. We have softwares available. We could, if you have the PDF, right? If you have the PDF, you can always integrate it numerically, right? And that's what QFunc function does in MATLAB, right? It does some numerical integration or some table-based methods or whatever. Okay, that's based on numerical integration. So एक आपके पास एक integral evaluate करना है आपने, अगर closed form exist नहीं करती, so what? So we can use a computer program to evaluate it. Okay, and that's a valid argument. But then what if I say, yeah, there are cases where you may not even have the PDF available either, right? And all you may have available, for example, are some parameters associated with that random variable, and that could be the mean, and that could be the variance, for instance. ठीक है? तो जैसे मैं अगर आपको कहूँ कि यार, all I know about a certain population is that population has an average age of 78 years, right? And that population's age has a standard deviation of 15 years, right? And that's all that you know. And I ask you, using just this information, can you try to estimate for me the probability that a person is going to live for more than 110 years, right? So the probability that capital X, which is the age, is greater than 110, which is X naught here, right? So I don't have any other information about the PDF. So I can't really go and integrate the PDF if right? Anyway, right? All I have is the mean and the variance. Is that enough for me to estimate, right? And it turns out we can define something called bounds, right? So we can try to approximate these tail probabilities through bounding operations. So we can not exactly, we will never be able to exactly compute what that probability is, but we may be able to say that this probability that you're trying to estimate is, say, less than some number. Okay? Less than this certain bound. And that gives us some idea, यार इससे नीचे या इससे ऊपर तो नहीं हो सकती, at least ये तो हमें पता चल जाएगा, right? And similar example you could apply for your aggregate. I say कि ये course है, उसका mean जो है 90 है और उसकी standard deviation 15 है. What is the probability कि जो है किसी ने 20 से कम score किया, right? And you try to estimate that through the bounds, okay? Or so 20. We're talking about the tail probabilities. What is the probability that somebody scored above a 20? Right? Can you estimate that or not? Okay. So these are the kind of answers that we want to be looking at, right? And for that, of course, I said, KG, we resort to something called bounds or inequalities, if you will. And the first of those we're going to study is called the Markov's inequality. Just for my my own information, have you heard of Markov's inequality before? In your undergraduate course, maybe? नहीं? Okay. Markov का नाम सुना है? क्यों मोहसिन? Have you heard about of Markov? Yes, Shoaib. कहाँ पे सुना है?
Within Markov model, first order Gauss Markov model.
Okay.
And so on.
Right. So Markov chains भी होती हैं. ज़्यादातर Markov chains से मशहूर है. Right. So this is I'm not exactly sure if this inequality is for the same is named after the same person, but it's some person I know. Right. So I know for sure that this is named after some person who derived this. Okay. So what this says is, and I keep saying this, कि यार ये पुराने सारे results हैं ना, वो लोगों ने अपने नाम पे रखे हुए हैं. Right? So I don't know why that is. I mean, there's Newton's law, there's Markov's inequality, Chebyshev inequality हम करेंगे. Gauss is the name of a person as well. ठीक है? So nevertheless, so suppose X is non-negative. So it only applies to non-negative random variables. Then the Markov's inequality states that the probability, the tail probability that X is greater than equal to X naught is less than equal to expected value of X divided by X naught. Right? So this is what it says, right? Where expected value of X is, of course, the mean. Okay. So let's do a quick proof for this. So this is fairly straightforward to prove. So I know that expected value of X की definition बताएं जरा मुझे. जी Maha, is your microphone working? Okay, so anybody else who can tell me definition of, so we're assuming a continuous random variable, okay? So the average value of X is?
X into f of X integral from plus infinity to minus infinity.
Yeah. So I just want to see कि यार कोई सुन रहे हैं नहीं सुन रहे हैं. Right, so this is the definition. And let me split up this integral into two, right? So let me integrate from 0 to X naught. And then let me integrate from X naught to infinity. Okay. And what can I say about these two terms? Are these positive or negative? Both of these terms. So in particular, what about this term? mean, can I say if this is definitely positive, or can I say if this is definitely negative, or can I say yeah, it could be positive or it could be negative? I mean, what? Ji Mohsin?
So you could say that it's definitely positive, since you know
Why?
that since you know that X is positive and the
Yeah.
PDF would be positive.
Yes, and the key here, of course, is that X is positive, and of course, the PDF can never be negative, right? So when you're integrating, the area of the curve, of course, always is going to be greater than equal, either greater than or equal to 0. Okay? So this thing is greater than equal to 0, right? If this thing is greater than equal to 0, I can claim that the expected value of X, therefore, must be greater than equal to that second term that was left there. Right? Does that make sense? Okay, I had the positive number being added to it, right? So that means it would have been a big number. If I get that out, so I'm going to get something smaller, right? So expected value of X had both of those terms together. One of those terms was positive. That means this sum of both of those terms is going to be greater than equal to one of those at least greater than or equal to one of those, okay? Because the other term is positive, right? So this is the basic idea of how we bound things, okay? Now I can do another bounding operation, and I say, yaar, this is also greater than or equal to, if I take x naught out of the integral, does this make sense now? Like, okay, I'm integrating over x, and as x as increases from x naught all the way up to infinity, this term here give me a minute. So computer stuck. Okay, so as I integrate from x naught all the way up to infinity, and the variable that I'm integrating over is x, okay? That x changes from where to where? That x starts at x naught and keeps on increasing from over there, okay? That means बाकी सारी जो आगे values हैं वो बड़ी है उससे x naught से, okay? So if I just replace all of those values with x naught, the answer that I'm going to get is going to be smaller, right? So therefore, this thing here must be greater than equal to this thing here, right? So that's another way I can bound these probabilities, okay? And what do I have? So what is this equal to? So this is x naught, the probability that x is greater than or equal to x naught, right? And this is now enough for me to prove, right? So this just means that the expected value of x जो है ना यार, that I know is either greater than or equal to x naught times probability that x is greater than equal to x naught, and this gives me the proof, right? Which is the probability that x is greater than equal to x naught must be less than equal to expected value of x divided by x naught, right? And of course, the assumption here is that x naught is greater than 0 as well. Okay, so proof is done. Now let's try to apply this to an example, right? So this bound, we've used some quite a little bounding as well over here in the sense that we've ignored this term here, यहाँ पे ignore किया, यहाँ पे ये ignore किया, right? So that means this bound, while it is accurate, I mean, there's nothing wrong with it. The probability that x is greater than equal to x naught is always going to be less than, always, no matter what the distribution is always going to be less than equal to the mean divided by x naught. Okay? That's what this inequality states. Now, how useful of an information does it provide us? That really depends on what the scenario is, right? G. Ali, you have a question?
सर x नॉट कैसे ले लिया आपने इधर? वो इंटीग्रेट करके भी तो आ जाता ना?
इंटीग्रेट करके क्या आ जाता?
x नॉट पहले वो x था,
Yeah.
आपने उसे x नॉट से क्यों चेंज किया?
And I've taken that out of the integral and I say that the left hand side is actually greater than equal to the right hand side. So this ये वाला key है. You see, this is the key. Right? I can take x out outside and I say that the left hand side is actually greater than equal to the right hand side. Get it?
Okay.
Okay. So my point once again was, okay, what if I gave you a situation where, let's do an example and I'll try to explain it from here. So here's the example. So consider x to be a random variable corresponding to the lifespan of a population. And let's say all you know about that is that we know that expected value of x is 78 years. Right? So this is not really Pakistan. I mean, does anybody have an idea of what the average lifespan of Pakistani population is? Kya khayal hai? Is it greater than 78, less than 78? So it's a lot less than 78, right? So yeah, so I think it's less than 60, I think. Okay, so but we can check nevertheless, right? So this is, let's say, some population, right, in the developed world, whose average lifespan is 78 years, and this is all that you know, and I ask you to find, what is the probability that the lifespan, or if somebody lives to be more than 110, right? And you have no more information available about these statistics. I mean, you don't know what the histogram is, we don't know what the PDF is, okay? Nothing else. All you have is the mean, okay? So the Markov's inequality would be a good means for you to be able to get some idea of what this probability would be, right? And the Markov inequality just says here, this is less than equal to expected value of x, which is 78, and divided by x naught, which is 110. And it turns out, KD, this is approximately equal to 0.71. Right? So this Markov inequality tells you that the probability that somebody is going to live to be above 110 years old in that population is not equal to 7.71, right? That's not what it tells you. It just says it's some probability, but that probability is just less than 0.71, right? This is all it tells you. Now we know that this is not really very nice information. I mean, it's आपको ये पता है 71% ज़्यादा नहीं हो सकता, लेकिन your real world knowledge tells you that this could not be this high. So we say that this bound is most likely not very tight. I mean, this does not give you a lot of information, right? It is valid, right? It is valid always. Valid का मतलब क्या है? कि the probability that somebody is going to live to be more than 110 is indeed less than 0.71. That's for sure. That's guaranteed. That's guaranteed. Okay? But how much less, we don't know, right? It could be anywhere. It could be 0.1, it could be 0.05, it could be very, very less. Okay? So this bound is sort of gives us a general idea, a very, very vague idea of what this probability should be. Okay? And I gave you another extreme example for this Markov's inequality, right? So what if then I asked you, okay, can you try to use a Markov's inequality to bound for me the probability that somebody is going to live to be above 70 years of age? ठीक है, what will Markov inequality tell you? So what is the probability that x is going to be equal to 70? Markov inequality मुझे क्या बताएगी? Which would tell me कि this is 78 divided by 70, right? Which is 1.1 something, right? So approximately, right? I mean, is this any good? क्यों ज़ैफा?
No, sir.
It's not good at all. I mean, ये तो मुझे पहले ही पता था यार, 1 से तो कम ही होनी है, of course 1 से कम होनी है, right? This bound, mind you, is not invalid, right? That does not mean this is invalid. All of this is telling you, okay, this probability is less than 1.1, and that's for sure. We know that it's great, less than 1.1. It's just that the additional information that is giving you is not really worth it. I mean, you already knew that, right? So the bound is not telling you anything additional. Okay, so they may be tighter bounds, and we're going to look at some tighter bounds in the next time around. Ji Ghazi?
Sir, expectation negative भी हो सकती है ना?
नहीं, so हमने, remember I said in the beginning कि Markov inequality is applicable to non-negative random variables.
सही.
ठीक है, तो फिर expected वाली negative नहीं हो सकती. By the way, Ghazi, अगर आप now if I tell you ना कि ये non-negative है, तो you should go back and immediately see कि यार जहाँ में मेरा proof था, उस proof में exactly where was the point where I needed that to be non-negative, and where was the point where if this was not non-negative, the proof would not hold. Okay, do go back and try to see, or yeah, that's actually in the red here, right? This thing, right? So actually
Yes.
यहाँ से यहाँ पे भी जाते हुए मैंने assume किया कि वो non-negative है, यहाँ पे 0 से integrate करना शुरू कर दिया मैंने. So do try to look that up, right? So I'm going to stop here and take any questions that you may have. Okay, no questions.